I wanted to start by talking more about quadrics, just to finish up the discussion we started last time. And as I said, drawing a 3D shape is very difficult in general, but what at least we want from you is to draw the cross sections. So I have my surfaces, a quadric surface will be something like f of x, y, z equals 0. Something like this one. This one could be what we just did a moment ago, x squared plus y squared minus z squared equals 1, for example, could be that shape. And then draw cross sections. At the very least, we want the cross section when z is 0. Those are the main 3 cross sections. Will be when z is 0, when y is 0, when x is 0. And those correspond to these would correspond to f of x, y, 0 is 0, which is it's a graph in the xy plane. And in this case, for example, it's x squared plus y squared equals 1, which is a circle. In the y equals 0, we would be looking at f of x, 0, z equals 0, which is a graph in the xz plane. In this case, they are some hyperbolas. And in the x equals 0, I get also, now I'm looking at a graph in the yz plane in 3D. And this graph tells me what's happening there. And it's, again, some hyperbolas. And those correspond to those hyperbolas here, the circle that appears here, and the hyperbolas that are also in there and there. Those sort of main lines, at least they give you a very good idea of what the overall shape is. If you can't see it in your head, what the shape is going to be, then you can draw more and more, and then you can see like, oh, the cross-section in z direction, there are circles, and they're increasing in size. That can help. OK. So this was the one I just did that for this surface. And I wanted to come back to this because this is what I drew at the end of the last class. And in a rush, this just looks ridiculous. It's hard to visualize what ended up happening. So it's much better if you just, once you have a good idea of what it is, then you just draw some of the main features that are representing the figure. So something like this, now it's a lot more pleasing to see what is happening, and then you can do, if you want, add some lines like this just to understand what's happening. But again, if you throw too many cross sections in one graph and every cross section is not drawn well, it ends up being a huge mess. But again, what I really want you to concentrate is to be able to draw cross sections in a plane. There could be questions that are sketch the graph, for example, this, sketch the surface of x squared plus y squared minus z squared equals 1. That's a question that can come up. You can understand what is the classification of quadrics to recognize that this is going to be a hyperbolic paraboloid and go from there. But again, if I'm grading that, I am not going to penalize because your drawing at the end looked like that, because that's how I drew it myself under pressure and in the pressure of time. But I do want you to be able to take this and tell me, oh, that is a hyperbola in the YZ plane. To represent the two-dimensional cross sections, that is the very first step to visualize what's happening. And it is at least what I would count as 4 points. I would like to see some sketches of the cross sections. The other thing I wanted to mention is that not every surface will come up in like the pretty form like this quadric. Sometimes the quadrics come in other shapes that is not immediate to identify what quadric this is. What you have to do, all the quadrics in the standard form are sum or difference of the squares equals a constant. So what you have to do is complete the square here so that it becomes some sum of squares equals a constant. Okay? So I'm not going to do that here because it's going to take me some time to do, but let me just, for example, I want to complete the square. There is an x squared minus 6x, and that I can simplify. That is going to be the beginning of a square. That's 3 times 2. So this would be x minus 3 squared, except that this square would have a plus 9, but there is no plus 9, so I have to subtract a 9. So this is, you can review how to complete the squares, but you can complete the squares in x, for example, here, to come up with like what equation that would be, and I've done this in the slide, and these slides I will post online, so you can see what happens. I can complete this square, and using that completion of the square, I can simplify this to this form, and therefore this graph is equivalent to this other graph. And now this graph, I know what it is, because this will be a paraboloid in the y direction. So this, if you think of it as a function of x and z, with the y being where the values are, this will be something like, this is the x, the y, the z. All the values are positive, and the vertex, you can see where the vertex is at 3, 0 in the x, in the xy, in the xz plane. So if I do 1, 2, 3, and 0, it's here, but plus 1, it all starts here. So eventually, it's going to be some hyperbolic paraboloid like that. Okay? You can do cross sections and do a better job of trying to understand what the graph is, but it's going to be a paraboloid starting from 3, 1, 0. So that point right here is 3, 1, 0.